Hello, our group is doing random testing using uniform or operational distribution. Random testing is randomly generating input and checking the expected output. If the output is determined to be wrong or if the system crashes, the input is saved to determine the problem so it can be fixed. This is typically done over and over with each new attempt containing newly generated inputs. Each failed case is saved to be studied when the random testing is finished. You can randomly test something millions of times while you walk away from your computer to find different unexpected crashes or bugs. So the way to do this is you choose your size, then you generate values of that size, and then use those numbers to create inputs and then test the outputs against the predicate or your expected output. Then if something goes wrong, you keep those input values, or you can simply save the number and generate the input values that way and test what you want to test. Here is a visual explaining how random testing works. First, you get your seed, which you can generate using a random seed generator, and then from your seed, you create your random set of inputs. You'll get the same set of inputs for the same seed, so if in the end you need to save your test case, you can simply save your seed. Once you are generating your inputs, you input them into your software system in the order that you want them to be, and with different gaps, and you can have either waiting periods or do the inputs all at once. It's all randomly generated. And then there's something called an oracle, which tests your inputs, tests the outputs versus the expected outputs. If the output works, then it simply starts over again. If the output does not work, it will save the test case by either saving the seed that generates the random inputs or saving the inputs, and then it starts over again. And it simply follows this loop over and over until you either decide to finish or until everything crashes. Here's another visual explaining how it works. We have multiple pseudo-random generators putting them random seeds into a lookup table to generate random outputs. You could have delays, you could have inputs, you can have different fields, and then the input simulator will put all of that data into the inputs. Once you are done with all those inputs and the output has been generated, the test response analyzer will determine whether the outputs are what should be expected from those inputs. For example, if the software crashes, obviously something went wrong, in which case it will save all of the inputs that were put into the system.
So the upsides to using this method of testing is you're able to test a wide range of potential unthought of use cases. You're also able to find defects from random inputs that you might not have thought of before. There's also something called fire and forget testing, which allows you to able to start testing and leave the test to do other things for any length of time while you do something else.
Downsides, there are many of them. A downside that we found in our research is that because the testing is random, some defects in the code or software that is tested may never be found. It is extremely difficult to generate a true random set of inputs. And the inputs that resulted in a failed test, they need to be saved. The saved failed tests are then reviewed at a later date or time. The reason to review and inspect these failed tests is to figure out where the execution went wrong or failed, specifically what line or lines of code did not produce the expected outcomes. And another downside is a lot of storage will be needed in order to store these test cases and outputs.
So when to use it? So usually the random testing we'll use it on a very large system or a very large number for the user to get the inputs. So obviously you won't spend a lot of time to testing a very large system. So that's why you want to set a sum of the parts to do the testing.
And here's a list of the citations we use to find and research what we made for this presentation. And just to recap, when you would want to save the inputs in the failed tests, it's because you would want to inspect them later to figure out where the execution went wrong or failed so you can address and fix the bug. And the upsides to random testing are that you're able to test a wide range of potential unthought of use cases, fire and forget testing, or you're able to start testing and leave the test to run for any length of time when you do something else, and you're able to find defects from random inputs. Downsides are that you need to save all inputs for the failed tests. Random testing is hoping you will find a defect randomly, which may never be found. Generating a true random set of inputs can be difficult, and truly random sequences cannot be compressed, and so a lot of storage will be required. And finally, what best defines random testing using uniform or operational distribution is randomly generating input and checking the expected output. We hope you enjoyed our video, and please subscribe.